So if you own a 3D printer, you're only halfway there. To get the most out of these machines, we need to be able to do our own design work. And if you're new to 3D printing or you just don't know where to begin, this is the video that's meant for you. I'm gonna be showing you my entire process, going all the way from a concept drawing to the finished 3D printed installed part we can actually test out and see how well we did. So stick around. In a previous video, I showed how to make these 3D printer mobile cards. They use up just about an entire sheet of plywood. So we need to work on some hardware here, and I thought this would be a great opportunity to show you all of my steps going from a concept sketch to a final 3D printed part that we can actually mount and test out as well. When I do any 3D printing, if I'm doing the design from scratch, I like to try and make it so that I don't have any support. So just find the final product is better. It's nice when you can take it right off of the build plate and start using it and not have to worry about the cleanup as well. The next is it needs to be super strong. And there are a few ways to accomplish that, both in the design, but then also in the way that we slice it for 3D printing as well. It needs to be super smooth, no getting caught on things as you're walking by them. And along the same lines, I've seen some other designs where they have these inset areas, and maybe that works in a perfectly clean environment, but when you have a dusty shop like mine, I'm gonna get dust in those as well if they have these inset areas. So we wanna have a completely smooth outside surface on there so that it's easy to wipe clean and keep everything dust free. We also need to think about when we're designing the way we're going to be 3D printing this. So there is a way to 3D print it where it's weak, and some of that has to do with the print settings, but then some of it has to do with the orientation as well. But my goal here is to come up with something that does not look like it's 3D printed, or at least you have to take a close look to know whether it is or not. So probably the first thing to talk about is, do you need to start with a concept drawing? And the answer is no. A lot of times I don't actually either. The idea would be that we have a kind of a unique flowing shape. It's got to be smooth, it has to be strong. I also want it to be pretty long. I think one of the standards for hole spacing is 192 millimeters. So I think that's a good number to try and stick with. So what I'd like to do is start with kind of an oval shape at each end. Kind of like this. And then it's going to transition into a diamond shape, diamond-ish shape here. And then back to an oval in the center. And then again, back to kind of a diamond shape here. So it's going to be a very unique, nice flowing shape. We're going to have some crisp, clean edges, and then we're also going to have some nice smooth curves on there too. Something like that, and it will hopefully look a lot better than this because really my drawing skills are not very good. All right, so we are going to have some holes in here too, and there will be some heat set inserts. And we'll try and get those as deep as possible. So these are going to be center to center, 192 millimeters. We are going to have a little bit of an issue when this is sitting on the build plate because we have some curves on the bottom. We also have some very, very sharp edges where we have the diamond shape as well. So on the bottom at least, but maybe on the bottom and the top, we would need to think a little bit about how that's going to go on the build plate, but also keeping in mind that this is going to be used for the drawer and the door too. So it should really look the same on both the outside, or the top rather, and the bottom. And there we have one of the designs. And I think part of the trick with 3D printing to make it look like it's not a 3D print is to incorporate shapes that are not just flat and straight. So this is going to have a lot of curves. It's going to be very unique in its final profile or final shape. So this is much more like what you'd normally see from a 3D print. It's very blocky, it's very beefy, and part of the reason for that is because if this is laying down like this, where we have the bottom, or I guess the final face, on the surface of the build plate, then we are going to end up with layer lines that come across like this. And if it's not beefy, this area here could be fairly weak as this is pulled. it could actually break apart there. So this is not really ideal for something that's slender. Instead, we could just tip this on its side and print it sideways, and we'll try that as well. So I will go ahead and we'll create a sketch going from the top down. I like to do that because I want the part to come in when I bring it into the slicer. I want it to come in the correct orientation right off of the bat. So that is going to be flat on the X and Y planes. So if we click on the top view and create a sketch from the top, and then this is really simple. We'll have a rectangle inside of another rectangle. And then just add some dimensions and we will constrain it. So 45 millimeters, I believe it was 220 millimeters, which is around 8.5 inches. And then for the inside, 35. For the inside is 30 millimeters. And each wing is 40. So if we create a center line or a line that we can reference, rather than over dimensioning this, we can use the constraints instead. So we don't need to dimension one side. I click on the symmetry button. I will click on this line, then the opposite, and then the center line, and it will automatically center them. And that way, when I change one dimension, it will change it automatically in both areas. I need to do the same for the others. And we can see what we're missing for the constraint. We need to constrain it to our origin point as well. And that we can do with a coincident. So if you can believe it, that is almost everything that we need to do. We just need to extrude it. And I like to extrude going in both directions, and that way I keep that original origin plane that I can use for later on if I want to. So symmetrical. And the overall thickness is 25 millimeters. And look at that, we have a handle that's almost ready to go. We are missing the holes, and we can definitely add those in. So we can create another sketch and add 2 points. And we were 192 millimeters, but we're halfway divided by 2. And again, symmetrical. And for the holes, I'm going to be using M4. Heat set inserts, M4 require 5 millimeter holes or just slightly over. I have them set to 5.1 millimeter. And the way I like to do the holes for these is add a light chamfer going towards the inside or countersink. And that just helps to prevent some of that excess plastic from oozing out too much, because all that needs to be cleaned up so we have a nice flat surface. So here we have a 6 millimeter. It could be 6.5, would work really well. So the next step is to add a fillet on the inside 2 edges, and we're going to do constant fillet of 3 millimeters. And this is actually ready to 3D print if we wanted to right now, but it is really, really blocky and it doesn't look very finished. So I do want to add some chamfers on here. So if we add a chamfer here of 35 millimeters, and we'll go 2 distance by 25. That looks pretty good. And we do the same over here. That is good. And then we can chamfer the tops and the bottoms as well. And let's just go with something like 7 millimeters. So here's where you can really play around with some of these little features and get a kind of cool look that you wouldn't be able to get otherwise. This one here is just your standard chamfer. And it's a bit unusual because it's not doing the exact same thing on the tops and the bottoms, but that's actually okay. That one looks pretty cool. We go to miter. That looks all right, but I'm not too happy with that. This one, this looks absolutely amazing. That little rounded detail on the corner just looks awesome. So that's the one I'm going to be choosing. And then I want to do one more chamfer, and that we can do with 3 millimeters. And go okay. And look at that. This took probably 5 minutes or less to design this. and it's pretty well ready to export. I do want to just take a look and see what it looks like when we render it. So already this is actually looking way better than I was expecting just by adding a few chamfers here and there. And I don't know whether this is going to look better than the other version or not, but we'll have to see when we get it mounted on the cabinet. So let's work on the next one. I've again added some dimensions here for reference. And this one's a little bit more complicated, but not really that bad. It is just a completely different approach to the first one that we did. And I think it's going to look really good when we're done. So what I'm going to do first is again start with a sketch from the top. But in this case, what I'm doing here is creating kind of like a skeleton, a framework that I can reference for the rest of the handle. And here I've already created it just so I didn't need to redraw it again. I will constrain it, and that way nothing can move around. So I have the outside on slight angles, that's 100 degrees, so it's only off by 10 degrees. And then I have this other reference line at 40 degrees out from there, and I'll show you what that's for in just a minute. 98 is just kind of a dimension that I came up with to make sure that the holes are in the right position. And now I can create a sketch on this plane. So we wanted to go from oval to diamond, back to oval, to diamond again, and then back to oval. So I could do this as a mirrored shape and only do half of it, but what I'm going to do instead is I'm going to draw out all of those shapes, all those 5 shapes, and there is a reason for that. I'll show you in just a minute though when we get there. So what I want to do is make sure that I project these endpoints. They are our reference points. And what we were talking about earlier is how is this going to sit on the build plate. So we need to have a slight flat section. We're going to do the same on the bottom as the top, that way it looks the same from both sides. That's really just meant for the door handle. If we were just doing it for the drawer handle, I would probably have the top complete instead, but it's going to be for both and it's just going to be simple that way. Okay, so that's good. And now what we can do is a plane along a path. So we want to have several planes. We want to have this one here, which is going to be set to a 0 distance. We want to have another one over here. Again, set to 0. And you can see those planes are really small. We can expand those just by dragging them out. And it's going to be here, and it's going to be 0.5, right in the center. And we can paste that oval. Okay, so we have all the ellipses, and actually this is usable as it is right now. What we could do is loft these, and let's see what that comes up with. So we get this shape, and if we play around with the ends, we can change the ends from connected to direction, and we can play around with how far out it comes. But it's not actually the shape that we were going for. So let's go ahead and add those diamond shapes. So we have all of those different profiles that we need, and we can then click on the loft and go from one shape to the next shape to the next shape. And oops, don't do that. And there we go. Now this is not exactly what I was looking for. This is a much more flowing shape. It does have some of those crisp lines. What I want to do is loft from this end to here. And then we can do the complete loft from one end to the other one. And this is what I was talking about earlier. If we had to have it only end at the center point and then mirror it over later, using the loft command, we'd end up with a slight straight section in the middle. It wouldn't look complete. It wouldn't be quite as flowing. So by doing it this way, we end up with a nice, smooth, finished product. And I'll show you in just a second. Turn off the sketches. You can see very continuous in the center there. It's exactly what I was shooting for. So this is nearly finished. I just need to add the holes on the back, and you saw exactly how that was done already. So there's one more little thing I want to add, and that's these interior corners here I want to deal with. So I'm going to use a fillet, and what I like to do is use a variable fillet. So it will change size, and we're going to have it go from 1 millimeter to 6 millimeters, and then from 6 millimeters back to 1. And that will reinforce that corner, so it ends up being a bit stronger as well. Not that it really needs it, but it's also a bit smoother on the inside too. And I kind of like the looks of that detail. That looks good, and let's give it a material. So I think this is going to look great. Let's move over to the slicer. So I'm in Bambu Studio. We can bring in the files. I have elliptical diamond and I have simple chamfer. And they should come in laying down just like we planned on. And I'll print one of each. So what I'm going to be doing is printing with the PETG carbon fiber. So we'll change the materials to PETG carbon fiber. So because we have these chamfers and some overhangs, we're going to get a little bit better result if we have thinner layers. And I am printing with a 0.6 millimeter diameter nozzle. We're going to get a little bit heavier duty part. If we do that, it will also be a bit faster too. And also our infill will be a little bit thicker, a little bit heavier duty. So we have these both exactly in the orientation that we want. Right now I've got a 0.18 millimeter. I'm going to change it to 0.16, and for the first layer we can change it to 0.2. And we also have these holes, and what I found with this material, PETG carbon fiber, is that it doesn't not like to bridge very well, even over these holes. So what we can do is we can turn on thick bridges, turn that on, and I found the wall from Classic to Arachne also works really well. That we have a variable width extrusion. And any areas like on the oval to diamond sections that are requiring a little bit different extrusion width, it should be able to do those really nicely. Now what we need is to look at the strength. So we have only 2 walls. 2 walls is not nearly going to be strong enough. I'd like something more like 6 walls, and the tops and bottoms I always go with either 5 or 6. It does depend on the layer thickness. Because we have really thin layers, I'm going to be adding a few more. And then we have the infill, and I can go with 35% gyroid infill. That's going to be pretty heavy duty. For a little bit stronger part, more walls tends to be better than just adding more infill, and the reason for that is because the infill is laid down very quickly. You get better layer adhesion if you add more walls. They're a little bit slower. So the only thing we have left to do is really look at the seam positioning. So let's slice this and see where exactly the seam position ends up. And if it doesn't look good, we can modify it. Okay, so the seam is not bad. In both cases, the seam's going to be on the back. And there are some settings for scarf, but I haven't perfected these scarf seams for this particular material. So I'm going to stay away from using scarf, at least for now on this one. But we can just draw it in. I do find to get a little bit better results when I have the seam all in the exact same position. We can slice that. We should get that seam right along that back edge. It's not going to be visible at all. Looks good. And we can do the same for here. In this case, we can draw it along this edge, or we can actually draw it right along here. So those are ready to send over to the printer, but another way to print this is going to be for the front of it to be down on the build plate as well. So we can do that. Same thing, we can copy this one over to this build plate and just lay it down like that. And because we designed this and it's so beefy on the ends there, I'm not worried about this one breaking. But like I mentioned before, if the ends were really spindly and really small, if we were to pull on that, it's very likely that it could break. And I like to make things a little bit extra heavy duty because I really just don't want it to fail over time. So I am doing more walls, I'm doing more infill than what some people might like to do. But the benefit of doing something like that is I don't need to worry about it breaking or wearing down over time. So I always like to do this. I know not everybody does it, but when you're printing heavy duty parts, they are much more likely to warp. So glue stick is a really good idea. If you're printing PLA and they're light, 2 walls and a light infill, it's not really critical. But heavy parts, I say it is a necessity. There you go. This being PETG carbon fiber, it's not going to be as big of an issue, and PETG in general isn't too bad, but it is definitely better just to add the glue stick and then not have to worry about wasting all that material and all that potential time. It just takes a second and it's really easy to rinse off too. So I'm going to have to break this rule and record a little bit with the door open. but it is a really good idea to try and keep it closed. One, for better sound, you're gonna have a little bit quieter print, but then the other is that the temperature from layer to layer is gonna be much more consistent, and you're not gonna see some visual defects between one layer cooling a little bit faster than another layer and producing a bit different results. We have a lot more contact area with the one at the back, and this is where, if you were to print something like this in ABS, you can start to run into some problems because it is so solid. We could use mouse ears to prevent it from coming up away from the build plate, but that doesn't always work. The stresses can sometimes be too high. So the one at the back is actually better for printing something like ABS. The one at the front should still work out. And again, we have the glue stick on there. Quite a few solid layers, and then we should be getting into some infilled layers shortly. See how we did. Ooh, that's nice. That looks really good. Very good. Let's take a look at this one. Oh, that looks great too. Top and the bottom definitely have a little bit more 3D printed look to them, but I do like that shape. Pretty strong. That's good. Yeah, that's good. So these are the M4 heat set inserts. I'm going to put them into here. Now I have one more of these printing right now in the red, and it's printing in this orientation. And I printed these two at the same time, but I also printed this one here. This is printed with a 0.8 millimeter nozzle. I wanted to see how that one would turn out. And the top, you can definitely see a little bit more of the 3D printed look to the top of it. But one issue that I ran into with this print is that because I didn't have two going at the same time, there wasn't really enough time for it to cool. And I had a little bit of an issue at the very bottom until I realized it, and I started adding a little bit more cooling into the print. So aside from that one little defect, it actually looks really good, and I think that's a pretty easy fix. Either print more than one at a time, or if I'm just doing one, then I need to add a bit more cooling. All right, so this is going to be the red cabinet. It has the red caster mounts on there. Okay, how does that look? Nice. Oh, what a difference. What a difference between grabbing it like this. Okay, I'm gonna get the other one mounted. A little funny because they don't match exactly, but I just want to show the difference between the two. Those need to be countersunk. Okay, so we have this really nice one, the lofted version with these super crisp and kind of semi-geometric corners, then curving in to this oval shape, but also on the end and the center too. You can see we have a little tiny irregularity there, and that seems to line up with the top of the hole, unfortunately. So there is a little bit of an imperfection there. You can't really see it unless you're close up. And this one here actually turned out great. The chamfered detail on its own is okay, but this curved edge just makes all of the difference. And that final little detail there, it looks a lot more complicated than it actually was to do. And I like the fact that this is big. There's lots of open space there behind here. This one here is pretty big too. There is enough open space to get on here too. And proportionally, it looks good on the cabinet. It's a little bit beefy and a little bit big, but I wanted that because I like the industrial look and I like this type of look too. Really, really thick, beefy, not gonna break, never gonna have a problem with it. So that is the final result for that one. But my favorite by far are these ones here. These are blue PETG carbon fiber. I printed 2 at the exact same time. And because I was able to do that, I don't have any issues with cooling on the overhangs, as you can see there. And the interesting thing is that these actually turned out better with the 0.8mm nozzle than they did with the 0.6. And I have a feeling it is to do with how it's treating these overhangs here. When it's bridging this distance, it's able to bridge better with the 0.8mm nozzle than with the 0.6. And then we don't have some of those issues, or if we do, you can see just barely in there. It's very, very minimal. So all we have left to do is get these mounted. And here's the PETG carbon fiber, which was printed laying down. Let's see how that one turned out. Yeah, not too bad. There's the seam here, you can see it's a little bit of perfecting on that seam, but the rest of it actually looks pretty good. So again, it's better to print something like this, which doesn't have very much cooling, in a pair, or just make sure that we add some cooling to it as well. But this is incredibly stiff. I can flex it just a little bit. But yeah, they look really good. This is more of the industrial look, and the other one is a little bit more artistic. So hopefully this video has inspired you to start doing your own design work, or to do a bit more design work as well for 3D printing. And I want to thank my patrons for helping to support this channel and making videos like this possible. And if you want to help support this channel, I have a list of products that I use in my shop on a regular basis that I know perform well. And thank you for watching. Take care, and I hope to see you on the next one.